Hello friends, in this video I'd like to solve the following problem from the Croatian Mathematical Olympiad, 10th grade 2003, problem number 3. Let a1, a2, and so on, up to an, be positive numbers where n is greater than or equal to, and let s be their sum. We wish to prove that a1 over s minus a1 plus a2 over s minus a2, and so on, is greater than or equal n minus 1. It's a pretty nice problem, very standard. Here are my hints. First, notice that both sides are homogeneous functions of degree 0. So we can safely assume without any loss of generality that s equals 1, for example. Or any other number which you wish. If you are not familiar with this notion, it basically means that a function is homogeneous if it satisfies the following condition. Maybe let's write it. F of a1, f of a2, f of an, if it's lambda times a1, lambda times a2, and so on, lambda times an, if it's lambda to the power of d, f of a1, a2, an, if this holds, we say that our function is homogeneous with degree d. Being homogeneous with degree 0 just means that if we multiply arguments by the same number, the value of our function stays the same. And that should be pretty obvious, because if I introduce lambdas both in the numerator and the denominator, the result is the same. So our function is homogeneous. We can safely assume that s equals 1. Why is that? Well, because if it's not, we can divide everything by s. And now we have another constant, which is 1. Variables are changed, and our s is also changed to 1. So it's justified. Then show that function which maps t to t over 1 minus t is strictly convex on this interval from 0 to 1 by differentiation. Yes, so investigate the second derivative. And finally, use Jensen's inequality. So give this problem a try, and I will see you in just a minute. Okay, so here is my solution. As I propose, as I justified, notice that both sides of our equation, of our inequality, are homogeneous of degree 0. So without loss of generality, we can assume that their sum s equals 1. Okay, and now let's define function f of t, which equals t over 1 minus t for t between 1 and 0. Okay, I wish to differentiate it twice. Maybe I will make my life easier by writing the following. F of t equals, I can do a trick, t minus 1 plus 1 over 1 minus t, and it is minus 1 plus 1 over 1 minus t. Very well, and now let's differentiate it. First derivative of minus 1 is 0, and derivative of this, it's using the chain rule, it's 1 over 1 minus t squared. And once more, second derivative is, well, we will have 2 this time, and by chain rule we have two minuses which disappear, and we have 2 over 1 minus t cubed. And notice that since we are in the interval from 0 to 1, this is definitely greater than 0 for t from 0 to 1, i.e. f is strictly convex. Strictly convex. Okay, very nice. And that means that we can use Jensen's inequality. By Jensen's inequality, well, by Jensen's inequality, it says basically that f of a1 plus a2 and so on, an over n is less than or equal f of a1, f of a2, f of an over n. So it holds for convex functions, but our function is convex, now we know that. Very well. And now let's just plug in numbers. What is f of a1, a2, and so on? Well, this, since a1, a2, and so on, their sum is 1 by our assumption, it's just f of 1. And what is f of, sorry, not f of 1, but f of 1 over n. And that is 1 over n over 1 minus 1 over n, also known as 1 over n minus 1. So we can multiply our inequality by n, and we can see that in fact n over n minus 1 is greater than or equal, but what is f of a1? F of a1 is a1, 1 minus a1. Then we have a2, 1 over a2, and so on, up to an, 1 minus an. And that is exactly what we wanted to prove. Yes, it's exactly that for s equals 1. And that closes our proof. One more thing before you go. Since our function is strictly convex, Jensen's inequality says one more thing, that equality is actually attained if and only if all of these numbers, a1, a2, and so on, are equal. So maybe let's write it. So moreover, equality is attained if and only if numbers in our numbers are equal. In every other case, there is strict inequality. And that's it. So I hope that you've learned something new this time. Jensen's inequality is very useful, and let's leave it at that. Thank you for watching. I will see you next time.